In this demonstration, we shall see one way to program a confidence interval calculation for the chi-square distribution. The formula for this is going to be the quantity n minus 1 times s squared divided by a chi-square value for one of the critical values. This is going to be less than sigma squared, which is the population variance that we're trying to estimate. And then that, of course, that's going to be less than the quantity n minus 1 s squared over another critical value from the same chi-square distribution. In this case, n is the sample size, s is the sample standard deviation, x will be the upper critical value for the chi-square distribution, y is the lower critical value. Notice this is an interval for variance. Square roots of these quantities will produce confidence intervals for standard deviation, and our algorithm will contain both of these calculations. So the first thing we're going to do is we're going to go to Program, we're going to go over to New, and we're going to type in a name, and I'll call this x2, go back to the alpha lock, and type in INTVL for interval. And as soon as I get this name in, I'll hit Enter, go to Program, go to I/O for input, and then I'm going to ask the user to input in the sample size. Now, if you noticed, what I did there is I hit VARS and then 5 for statistics. That brings up the option to bring in the statistical notations that the calculator already has programmed in. That's where I was able to get the little l or the little n from. So we'll go to second, and then we'll go ahead and do a colon, close the double quotes, and we're going to store the sample size as n. Now again, we'll go to Program, I/O, call up Input, open up a statement with a double quote, and then we're going to go alpha. Sorry, we don't hit alpha there. We close that. We hit VARS. We go to 5, and here we see some of the statistics notations. So we called up n already. Now we're going to call up SX, our standard deviation notation. We'll go ahead and do a colon for that. And we'll close this, and we'll call this S. And then the next thing we're going to do is we're going to input in our confidence level. So we'll do input command, open quote, type in C, use the minus sign as a hyphen, and then we'll type in the word level, L-E-V-E-L. Then we'll do a colon, and the double quotes, put a comma, we'll call that C. And then again, in order to get our critical values that we're going to need, we're going to do the quantity 1 minus C. So we're going to place 1 minus C in parentheses. Then we're going to divide that result by 2, and we're going to store this result as A. This will be used to find our critical values that we need. So next thing we're going to do is we're going to go to Math. We're going to hit the up arrow once to go to Solve. That brings up this Solve command here. And when we do this, what this is activating is the algorithm's solver command. And this uses a Newton's method of variance, a variant of Newton's method, which you study in calculus, to solve. So we'll go ahead and call that command up, and then we're going to hit second and VARS to get the distributions that we need. And then we're going to go ahead and hit option 8, which is the chi-square CDF command. Now, for this to happen, we need a lower bound. Chi-squareds don't go any lower than 0 because they're squared variables. So we'll go ahead and use 0. And then our upper bound will be x. That's the number we're trying to find. Our degrees of freedom are going to be the sample size, which we stored as n, minus 1. And then we'll paste that into our algorithm. Now we're going to do a minus here because we need to subtract off the area for A. Now the solve command will say, here's your equation. It's assumed to be equal to 0. So we had to subtract A. So we could say, hey, this chi-square CDF minus the A should be 0. So that's what we're looking for. And then we're going to say I want you to solve for x. So I'm going to do comma x, then comma 0. That's my initial guess. I'm going to close that command off. And then I'm going to store this value in the letter L. I'm going to repeat this. I'm going to go to Math, Solve, go back to second variance for distribution, call up the option x chi-squared CDF, type in 0 for the lower bound, x for the upper bound, n minus 1 for the degrees of freedom again. And I'll go ahead and paste that back in. Then I'm going to minus the quantity 1 minus A. This will give me the right critical value. So I'll do a comma and then an x, that tells the solve that I'm solving for x. A comma 0, that tells it to start your guesswork at 0. Then we're going to store that under the letter R. And now I'm going to go to Program, Input, and I want to display the result. So we'll go to opening up with a double quote. We'll go C minus sign for a hyphen, and then we're going to type in the word lower. This will be the lower bound on the confidence interval. We'll go ahead and do a colon and then end the double quotes. And we'll put in a comma. And this time we're going to type in the left side of that formula that was given at the beginning, that you can also see here. So we have n minus 1, then we have s squared, and then we're going to type in this. Remember, x is the upper critical value. We defined it in r in our algorithm. So we have r squared here. Or r, not r squared, sorry. Then we're going to repeat this. We're going to display, open double quotes, and we're going to do the upper bound. So C minus sign for a hyphen, and then type in the word upper, and that's going to give the formula here. So we'll go ahead and close that double quote, put a comma in, and then we'll type in a similar thing over here, where you have n minus 1, s squared. Now that y squared on the bottom, that is the lower critical value, which we defined as L. So the squares on the x and the y in this formula are part of the notation, and that's just typical of what we see. Okay, so we're going to pause this, because remember, we're also going to output not only the confidence interval for the variance, but we're also going to output the confidence interval for the standard deviations in case you're looking for both. So we're going to repeat this, except this time we're going to do a pause, so you have time to write down your results. And now we're going to have the calculator display a short little message that says, hey, the next results are for the standard deviation. So we'll go back to Program, I/O, and then Display. And this time we'll do, again, that C lower. And again, this time we'll do the square root of that result that we typed in at the very top up here that you see up here. We're going to do the square root of that now. So we do square root, and then we say n minus 1 in parentheses. And then we're going to multiply that by s squared. And we're going to divide that by r again. And then we're going to close that square root. And then we're going to display. So we'll go Program, I/O, Option 3, Display. And we're going to do C upper for the upper bound on the confidence interval for the standard deviation. So we'll type in C, minus sign for a hyphen, and we'll type in the word upper. And we'll do a colon and the double quotes, comma, and then the square root of that quantity we see at the top of the screen here. which is n minus 1 in parentheses, and then multiply that difference by s squared. We're going to divide that by L, and we'll go ahead and close off this square root. Now this is essentially the finish of our algorithm, but we need to test this. So we're going to go ahead and test it with an example where we already know the information. So we have a 95% confidence interval for the variance when given a sample standard deviation of 0.15 and a sample size of 10. Okay. We shall also consider a confidence interval for the standard deviation for the same information. So basically our confidence level is 0.95, our sample standard deviation is 0.15, and our sample size is 10. This is just going to be something for us to test. So we'll go ahead and quit out of here. We'll go ahead and call this program. I'll go ahead and use alpha x to call up the chi-square interval stuff. Our sample size was 10. Our sample standard deviation is 0.15. And our confidence level is 0.95. And we'll go ahead and let this run for a few minutes. And again, it's going through doing those values. And here we get the lower and the upper at 0.016 or 106, and the upper is 0.074. Now remember, the first thing that this algorithm outputs is the confidence interval for the variances. Okay? So notice the algorithm is paused, and what we're going to do is we're going to hit enter again, and we get the standard deviation values at 0.103 for the lower bound on the confidence interval for the standard deviation, and we get 0.273 for the upper bound on the confidence interval for the standard deviation. And this is one way to program in an algorithm to find the confidence interval for a population variance or a population standard deviation using chi-squared distributions.